All right, we're gonna pick up right where we left off in last video. So last video, we went over 1 through 4. We're starting with number 5. So using our same steps, we need to isolate one radical on one side. You already have that radical isolated. So now we need to raise each side of the equation equal to the power. So this is a square root. So I am going to square both sides. On the side, the square root and square cancel each other out, leaving 40 minus 3x, and x squared is x squared. And the first 4, once I got rid of that radical, it left behind a linear equation. I now have a quadratic. So this goes back to last lesson. Because this is a quadratic, I need everything to one side of the equation. I need to put this into standard form. We typically want this x squared to stay positive, so I'm going to add my 3x over and subtract my 40 over. So now I'm going to have 0 equals x squared plus 3x minus 40. Now we have 3 ways to solve a quadratic: by factoring, square root method, and quadratic formula. I can't use the square root method because I have this x right here. So I'm left with factoring and quadratic formula. Now, quadratic formula will work for all of them. If you don't like factoring, get familiar with the quadratic formula. That's what you're going to have to use. But I like using factoring if these are factorable because it's a lot quicker. So I'm going to go into my x. My a times c is 1 times negative 40. My b term is this 3. What adds up to 3 but multiplies to ac. If you need to, pause the video so you have a little bit more time to try to figure it out. List out your multiples if you need to. But this is 8 and negative 5. So when I multiply, we get to negative 40. When I add, I get to 3. Now, luckily, this is an easy trinomial since a is 1. So this factors to x plus 8, x minus 5. When I set these individually to equal to 0, we get x is negative 8. And we get x is 5. Now, before we are done, step 4 says to check. We've got to check them all into the original to check for extraneous solutions. So this time when I check, I need to check both of these. So if I start with x equals negative 8, I am plugging in that negative 8 into both of these x's. So we will have the square root of 40 minus 3 times negative 8. And I am wanting to know, does that equal x? Does that equal negative 8? Now, from last video, whenever I have a square root equaling a negative, this is never going to work. So I can tell you right now, this one doesn't work. But if you went through, you would see that. We would have 40 plus 24. That's going to give me 64. And the square root of 64 is not negative 8. It is positive 8. So this is not a solution. This one is extraneous. So now let's move on to check 5. Now I'm going to plug in a 5 to both of these here. So we have 40 minus 3 times 5. And I'm wanting to know, does that equal x, which is 5? So let's work this out. This is going to be 40 minus 15, which is going to give me 25. And the square root of 25 is 5. So that is my solution. We have only one solution here when x equals 5. On number 6, step 1 is to isolate one radical on one side. On this side, I have a radical minus 4, so we need to move that over. So now I have, what do I have? I have x plus 4 equals the square root of 3x plus 10. Okay. So now that I have isolated one radical, now we're going to raise each side of the equation equal to the power. The opposite of squaring is, or opposite of square rooting is squaring. So now I am squaring everything on the left, everything on the right. So let's talk about this left side first. We have done this before in Module 2, Lesson 1, when we were going over the difference quotient. We came off to the side. There was a little square in that bottom right-hand corner. You cannot just distribute this square and say that this is x squared plus 16. What we need to do is expand this out. This is x plus 4 times x plus 4, and now FOIL. So your first is x times x. Your outer is x times 4. Then we'll have inner 4 times x. And then outer 4 times 4. Combine your like terms. And so this is x squared plus 8x plus 16. If you just distribute that 2, you miss out on this middle term right here. Right? And this is going to equal on this side here. My square root and square cancel, and I am left with 3x plus 10. So what kind of equation do we have? Because of this x squared, we have a quadratic. So I need to get everything to one side. So I'm going to subtract my 3x over, as well as subtract my 10 over. So I have x squared plus 5x plus 6 equals 0. So now let's factor. Because it's a trinomial, we'll go into our x. My a times c is 1 times 6. My b term is 5, but adds up to 5, but multiplies to 6. Please pause the video if you want more time. That's going to be 2 and 3. Because this is an easy trinomial, meaning my a is 1, this factors to x plus 2, x plus 3 equals 0. So when I set x plus 2 equal to 0, we're going to get x equals -2. And when I do x plus 3 equals 0, we're going to get x equals -3. Now, before I can box those and say those are our answers, we have to check them. So I'm going to check x equals -2 first. Plug that into the original into both of these x's. So we have -2 equals the square root of 3x plus 10 minus 4. Now, I cannot say that this one is automatically a no solution like I could before. With this one here equaling that -8, it was only a square root equals a -8. But this one's not only a square root. This one is a negative equals a square root minus 4. This minus 4 makes a difference. So this one we need to work out. So we've got negative 2 equals, and of course, by the way, I'm wanting to know, do these equal the same thing? So, and I forgot to plug in a negative 2 for this x here. So let me do that. Squeeze that in there. So when I start evaluating, I'll actually start right there. This is negative 6 plus 10 minus 4 on the outside. This is going to give me the square root of 4. The square root of 4 is 2. And 2 minus 4 is negative 2. So this one actually works. So because this one works, can I just automatically say that this one doesn't work? No. These could both be my solutions. When I have two possible solutions, I could only have one, or I could plug them both in and they're both extraneous and have no solutions. So you always need to check everything because it could be none, one, or even two. So we'll check negative 3, and I'm going to plug this in this time to both of my x's. So negative 3 equals the square root of 3 times negative 3 plus 10 minus 4 on the outside. So do these two sides of the equation equal each other? Let's work it out. And again, I can't just throw it out and say this because it equals a negative number. It can't work because of this minus 4 outside of that radical. So negative 9 plus 10. Negative 9 plus 10 is 1. And the square root of 1 is 1. And what do you know? 1 minus 4 is negative 3. So here we have two solutions. So don't just throw that out because one worked. It's not a guarantee that one's extraneous and one's not. And then our last one here. And this last one, we will actually be using all of our steps here. Step 1 is to isolate one radical on one side of the equation. This radical is not isolated because it's got 15 minus that radical, but this one is. And that's all it says, is to isolate one radical on one side. So we're done. So raise each side of the equation equal to the power. These are both square roots. So we will square both sides. My square root and square cancel on this side. I'm actually going to leave that alone for a second. I want to work this one out the same way we did right here. When I have 15 minus the square root of x, that means this is 15 minus the square root of x times 15 minus the square root of x. You have to expand that out and then now FOIL. So 15 times 15 is 225. 15 times a negative square root of x is negative 15 square root x. Negative square root of x times 15 is another negative 15 square root x. And then here, negative times negative is positive. The square root of x times the square root of x is x. The square root of x times the square root of x equals x. Why? Multiply what's under those radicals together, and we're going to get the square root of x squared. Well, squaring and square rooting are opposites. So they undo each other and we're left that x. Okay, let's combine our like terms here. And so we get, if I bring this down now, x minus 75 equals 225 minus, these are like radicals, so negative 15 minus 15 is negative 30 square root x plus x. Okay, now step 3 says if the equation still contains a radical term, we need to repeat steps 1 and 2. I have a radical term, so now I need to isolate this. So to isolate this, I need to move the 225 over and move the x over. When I move x over, both of these cancel each other out. So now I'm left with just this equation right here. So now I will subtract my 225 over. That's going to cancel. So I'm left with negative 300 equals negative 30 square root x. I still have not isolated this radical. So this is negative 30 times the square root. The opposite of multiplying is to divide. We're going to divide that over. We're going to get 10 equals the square root of x. So now my radical is isolated. So now step 2, raise each side of the equation to the power equal to the index. The opposite of square rooting is to square. So I'm going to get 100 equals, those cancel, equal x. Before I am done, I've got to check this into the original. So we'll have the square root of 100 minus 75. And I want to know, what do I want to know? Does it equal the other side? So 15 minus the square root of 100. Is the left equal to the right? So I'm going to simplify the left and then I'll come back to the right. Here we have 100 minus 75, which is 25. And the square root of 25 is 5. Over here, the square root of 100 is 10, and 15 minus 10 is 5. So yes, this is my solution.